Please confirm if my screen is visible. No? Can someone confirm? Okay, I think we are good to go. So what were we discussing in the last class? In yesterday's class, we were discussing about Java literals, right? So what is a literal? Literal is just a constant. Yeah, I can say that it is a data or it is a value. Okay, that is getting assigned to the respective data type. Okay, in this example, we have seen this is a number. Okay, and this is a literal. Anna University is a string. It is a literal, and 1000.5656 is a floating point value. This is a floating point literal, and m is a character. It is a character literal, right? So again, they are classified into four types. You have discussed this yesterday. The first one is integral or integer literal groups, floating point literals, boolean literals, and string literals. So these are the data types that comes under the integer literal groups. So byte, short, int, long, and and also in addition we have something like char. Okay, so we have discussed these things very clearly yesterday, and we have seen about floating point literals. And when it comes to floating point literals, we have only two data types. One is float, second one is double. If you want to represent the price of the petrol or the account balance with high precision, you can go for these two literals. Okay, depends upon the size. And again, we are going to discuss about the size as well. We are going to dive deep into it. And you have the string literals. So if you want to represent any, and we have seen about Boolean literals, you can represent only two values, either true or false, right? And also we have seen some example about this Boolean literal, right? And also last thing you have discussed about the string literals. So by this I can conclude that the literals are completed. Today we are going to start an interesting topic about what the name of the topic is, number systems. Okay, so this is very important to understand all the primitive data types. To understand all the primitive data types, this topic is really important. So what is the name of the topic? Number systems in Java. Okay, so in Java, if you talk about number systems, Java supports four number systems. Okay, one is what? Binary number system. Binary number system. Second one is you have something like octal number system. Octal number system. And you also have like decimal number system. And the last one is hexadecimal number system. Hexadecimal number system. So we're going to discuss each in detail. Okay? And each and every number system has a significant importance to develop the Java programming language. So that if you understand this number system, understanding the primitive data types and the internal things are going to be very easy. Stay focused. Okay, I can say that I can conclude something like, please be informed that to represent any numbers in any programming language, not only Java, to represent any numbers in any programming languages, we need to understand the above number systems. Understand the above number systems. Right? And also, if you get a question like, what is the default number system in Java? What is the default number system in Java? The answer is very simple. Java, the default number system in Java is what? Is decimal number system. Okay, we might have seen this number system during our graduation, right? But we will understand this once again with respect to Java programming language. So firstly, we will try to understand what is this decimal number system. So when I say decimal number system, okay, I can just say it like any numbers that can be understood by the human beings. Any numbers that can be understood by the human beings, okay, we call those numbers as the decimal number system. When I say that, for example, okay, so let me keep it very simple. Okay, see guys, let us say that I have a number like something like 734. Okay, so we human beings, we can interpret this and we can just read it like 734. If you are literates, any human being can read this number 734. If I want to expand it further, how I could do the expansion? I can also say it like, I can just pronounce it like the way I am pronouncing it. Just say the way I am pronouncing it, 734. This is how my pronunciation is, right? What did I pronounce? 734. Okay, let me keep it more simple. This is how I am going to pronounce it, 730. If I ask you to pronounce this is how you would pronounce it, right? 734. Okay, the combination of 700 plus 30 plus 4 is going to give 734, right? But I want to break down further. I want to do further breakdown. I want to rewrite this in a different format. How I can do that? The 700 can be rewritten as 7 into 10 to the power of 2, followed by this 30 can be rewritten as 30 into 10 to the power of 1, followed by this 4 can be rewritten as 4 into 10 to the power of 0. Making sense? And if you ask me, so we are trying to do what? We are trying to break it down by using a typical conversion, in the form of base 10. If you see, whatever the number you take, it could be the multiples of 10 only, depending upon the placeholders. Right? If you see the significance of the power, the significance of the power is increasing from 0 to and so on. I mean 0, 1, 2 and so on. It is going to, it keeps increasing. Okay, that's why they say whenever you represent the decimal number system, the base is always 10. When I say base, when I talk about base is just, this is the base. Okay, when I say 734, you see, you just read it like 734. No matter if you place 10 or if you don't place 10, usually we don't place 10 under this. You don't represent the base value. Even though, no matter if you represent or if you don't represent, the decimal number system is going to follow what? The base for the decimal number system is always 10. Making sense? Okay, let me take another example. Okay, let me take another example. Let me remove this. Now focus here. People who have just joined now. Okay. Now see, I have some number something like 6594. Okay, I want to pronounce it, right? How do we usually pronounce it? 6000, okay, 500 and okay 90, okay 4. The combination of 6000 plus 500 plus 90 plus 4 is going to give what? 6594. Okay, if I want to break it down further, I can do it with the multiples of 10. 6 into 10 to the power of 3 plus 5 into 10 to the power of 2 plus 9 into 10 to the power of 1 plus 4 into 10 to the power of 0. Okay, the power of okay, the power of something. Okay, the power of something. So that something is what? 10. I mean, significant of the powers are increasing from 0 to the natural numbers 1, 2, 3, 4, 5. Okay, whatever number you can take, you can break it down with the multiples of 10. That's why it is called decimal number system is represented with the base 10. Making sense? This is how the humans read. And also by this I can easily conclude, right? By this I can easily conclude that, okay, so this decimal number system are used by what? Used by human beings. We use this decimal number system to perform the day-to-day activities, day-to-day calculation, to develop any scientific application, like to calculate any formulas, whatever that we choose, whatever the mathematical operation that we perform, we go with decimal number system, because this is how we are designed. This is how humans can understand. Yes or no? Likewise, even in Java also, that the default number system is what? The default number system is decimal number system. Okay. Having said this, see, how many numbers can I represent by using decimal numbers? What are the possible numbers that I can use by using decimal number system? I can use 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay. These are the possible numbers, right? Possible numbers. Do we have any other numbers apart from this? So whatever, even if it is a small number or even it is a big number, okay, the combination of all these numbers, the permutations and combinations of all these numbers is going to represent any number. If you want to represent a number like 91, okay, and again 91 is from where? From where? From one among this, right? You choose 1 9 and you choose 1 year. There are no other numbers apart from this. Okay, why I am telling you all this? Because this is how we read. Okay, I can conclude that the base of the decimal number system is always 10. Please be informed that the base of the decimal number system is always 10. I can say 10. Okay, because the significance of the power increases from right to left against the what? Against the number of digits the number is. So what do it really means? If you have something like for example 2 3 4 5, okay, and I want to represent, okay, I want to break it down. 2345, 2000 plus 300, yes, plus, and you have 40, yes, and plus you have 5. Okay, if I want to break it down further, I can just break it down with the multiples of 10. Okay, so this is how it could be broken further. 2 into 10 to the power of what? 10 to the power of 3. Okay, so 2 into the power of 3 plus 3 into 10 to the power of 2, right? Plus 40 into 10 to the power of 1 plus 5 into 10 to the power of 0. Okay, and if you look at the power, if you see the power 10 to the power of something, if you see the significance of the powers, if you see, it is increasing from left to right to left, from right to left, from 0 1 and 2 and 3 and so on. It keeps increasing like that. And apart from that, if you see, it is always the multiples of 10. Whatever the number you take, it is always the multiples of 10. That's why it is what? It is always, the base is always 10. Okay. So just tell me, type S in the chat box if you have understood about decimal number system. You might be thinking, sir, we have know this already. We have completed our graduations. Don't teach us once again. Don't think like that. So these things, we have a significant importance to understand the remaining topics, right? So this is how the decimal system works. Now, if I ask you a few questions from here, you can say, okay, you can conclude that, okay, Java, if someone is asking you what number system in Java is applicable by default, okay, what could be the answer? The possible answer is, for the one and only answer is, the default number system is Java is decimal number system. Okay, I mean, when the decimal is coming into your mind, always remember it is of base 10. Base 10. You cannot change this. Okay, now let us start understanding about binary number system. Why this binary number system has been introduced. Okay, second one, binary number system. Okay, why the concept of binary number system has been introduced? So what is the story behind that? What is the actual story behind that? Okay, if you see computers, if you see the computer, for example, focus here. For example, if you have something like 100, okay, 100 is a data, right? And if you want to store this data into the computer, you require a converter. You require something called what? You require a converter. any number that you give, any decimal number that you give, okay, this decimal number cannot be stored by the compile or cannot be interpreted by machine. Let us say that this is a machine, any electronic machine. Okay, machine means it is not necessary that it should be computer, any electronic device or any electronic machine. Okay, so if you want to store this 100 into this electronic machine, okay, there should be a converter. This converter needs to perform some conversion. What kind of conversion it needs to perform? What kind of conversion it needs to perform? It has to convert the decimal number, in whatever the number you give, it has to convert this to zeros and ones. Okay, because the machine can understand either sequence of zeros and ones. This number may represent a sequence of zeros and ones like this. Since it is a number, okay, machine can understand, and there should be a converter. This converter will ensure that the 100 is represented in the decimal format should be understandable by the machine language. So it has done some conversion. Now this machine will understand, okay, this is something like, for machine it is 100. For us, this is how 100 looks like. For the machine, for the electronic machine, this is how the 100 looks like. Someone has just joined. A minute. Okay, likewise, if you take any other data, now number is very specific. To take something like a string literal Balaji, okay, and you want to store this Balaji into the electronic device. A converter is required. This converter will also ensure that the string data or the alphabetical any English information, any English words could be converted. Because how this conversion is happening, each and every letter is assigned with an ASCII value. A number, just for what I can say that, so there are some numbers that is representing ASCII value of certain letters. So Balaji will represent a number like, I think, 97. Okay, as according to the ASCII value. Right, and small a, I think it is going to represent 65 according to the ASCII value. Again, it will get converted to number firstly, and again that number will get converted to what? Zeros and ones. Because this is how machine will understand. Okay, we understood about storing the integer. We have understood about storing the string character. What about storing the what we call it as any audio? If you have any audio, right, you send audio messages, right? How these audio messages are converted? Even these audio messages has to get converted. Even the audio messages has to get converted in the form of zeros and ones, and the converter will come into the picture. Okay, how this converter will ensure that the right conversion is happening? So audio is all about pitches. Okay, there will be some pitch like this. There will be some high pitch. Okay, based upon the pitch values. For example, if you're sending audio with this kind of frequency, okay, when you say I, just imagine that a sine wave is created. For I, a frequency is created. Okay, based upon this pitch value, okay, it will understand this audio will also get converted to zeros and ones. The pitch is very high, it is going to be 1. If the pitch is very low, it is going to be 0. The combination of 1 0 0 1 0, any binary combination. Right, even this audio will also get converted to 0 1 0 by by the converter. And even if you send a video, even that video will also get converted to zeros and ones. How it will get converted to zeros and ones? The converter will take care in such a way that, right, each and every pixel, if you zoom inside the video, if you keep zooming any video, okay, you will find at the end, you will find pixel. Okay, or red, RYB, all the combination of red, yellow, blue. Okay, that pixel will represent a certain binary numbers, a certain sequence of binary number. For red, it could be like 0 1 0 1. For green, it could be like 0 1 0 1. The idea is whatever the input you give, whatever the data that you give, okay, to any electronic machine, if the electronic machine needs to understand the data, the data needs to get converted to the binary number. Only the electronic machine will understand zeros and ones. Having said this, there is only one number system which can help us to perform the right conversion, right? So we are talking about zeros and ones. If for the numerical data, zeros and ones. For the string data, again zeros and ones. For audio, again zeros and ones. For video, again zeros and ones. Okay, what is the number that is going to represent only zeros and ones? Binary number system. Yes or no? So this is the idea behind this thing. Whatever the data that you want to convert, it has to get converted in the form of the machine language. The machine can understand only zeros and ones. To ensure that the actual conversion is happening, you need to go for what? Binary number system. You should understand what is binary number system. Making sense? Any confusion? So we need this to understand data types. I am going just little deep. Say something. Yes, no. Everyone, we are just going into binary number system. So why it is required? I'm just giving you that. Come on, guys. Type. Say yes or no in the chat box. If it is no, just say no. I will again repeat it in a different way. Okay. If it is only yes, say yes. Now see, guys. Even if you don't remember also, no issues. Now let me tell you something. I can directly say, if you ask me what is binary number system, I can directly say the number system which can be represented with two numbers. Okay? It could be zeros and it could be ones. Okay? For the decimal system, we have totally how many numbers? We have totally 10 numbers including 0. But for binary number system, you can use either zeros and ones. Right? They are called as binary number system. Okay? So they are used by the machine to perform manipulations. Used by the machine to perform manipulations. Okay, so let us understand this in a different way. Let us say that I have a system, guys. Okay, let us say that I have a small computer. Okay, so when I talk about the computer, you talk about the hardware and also you will talk about the software things. Okay, the computer architecture basically, and you have a CPU. Okay, inside the CPU, definitely always, okay, if you are going to purchase a computer, we always give priority to two things. One is processor and second one is RAM. So let us say that my computer has a RAM capacity. My computer has a RAM capacity of about 4 GB. 4 GB. 4 GB means it is something. The RAM is, you can do many operations by using this 4 GB RAM. Right? You can possibly develop an application. You can do a lot of things just by using this 4 GB RAM architecture. Right? So if I ask you 4 GB, that 4 GB is talking about the memory size. And you can also talk about something like 8 GB. Okay, the size of the RAM keeps increasing. 12 GB RAM is also there. Okay, 18 GB, 16 GB RAM is also there. It keeps increasing. If I ask you about the smallest memory unit, if I ask about the smallest, for the biggest memory, you can go with the terabytes, gigabytes, petabytes, so many things. But if I ask you what is the smallest unit in the memory, okay, so I can say that bit. There is a concept of bit. Okay, one minute, guys. Okay. If you keep dividing, if you divide this 4 GB into two parts, okay, you see what you see, you get 2 GB, 2 GB, 2 GB. And again, if you divide this 2 GB into two parts, you get 1 GB. Right? And again, if you divide that 1 GB into two parts, you get what? You get something like 520 KB, MB, if I am not wrong. Okay, and if you keep dividing, there will be a place where you cannot divide further. You will reach a saturation point from where you cannot divide it further. That place is called as what? That place is called as a bit. So I can say that bit is a smallest unit of memory that could be used to store a data. Smallest unit. So after, there is no other smaller memory area than the bit. This is the smallest memory unit. Bit is a, please be informed that the bit is the smallest memory unit to be used to store data. Okay, so when I say one bit itself is a smallest memory unit. Okay, the combination of 8 bits is going to give 1 byte. 8 bits is going to give what? 1 byte. Okay. If you ask me, is there any other memory unit apart from 1 bit, smallest memory unit apart from 1 bit? No, this is the last one. This is the least memory unit. This is the smallest memory unit. Right? 1 bit is the smallest memory unit. Right? Having said this, let me use this place. Now see guys, I say now I have bought a system. Okay, this is my RAM. Now I am saying my RAM capacity is just 1 bit. The capacity of RAM is 1 bit. Previously I was saying that my RAM capacity was 4 GB. Now I am saying that I have bought a system. My RAM capacity is just 1 bit. If you have 1 bit, what kind of data that you can store? What kind of data that you can store? You can store, possibly you can store two information. Either you can store 0, okay, or you can store what? Or you can store 1. Either you can store 0 or you can store 1. If you want to store 0, you can store that. If you want to store 1, you have to remove this 0 and you can store this 1. Okay. Only 2 pieces of information you can store at any point. I mean, only 1 piece of information you can store at any point of time. It can be 0 or it can be 1. For 1 bit, there are 2 possible data, 1 or 0 you can store, but any point of time only 1 piece of information can be stored. It can be 0 or it can be 1. Okay, this is the idea to understand about the memory units in the system, memory units in the programming languages. Here what they said, so they have calculated machine can understand either 0 or 1. Okay, so by this understanding they start representing this one as what? True. The indicator of 1 is what? True. And the indicator of 0 is what? False. And they also started saying you can either call it as true or you can either call it as yes, or you can also call it as no. Apart from this, they have further expanded it by saying that it's not only true or false, it's not only yes or no, it can also represent on, it can also represent off. Right? So if you have 1 bit of memory, in your system, you can store these many possible values. I mean, you can store either 0 or 1, or you can also understand it like true or false, or yes or no, or on or off. Right? In the earlier days, they used to do a communication by using, before the invention of computers, even before much before the invention of electronic device. So how the communication was like, let us say that so this is me. Let us say this is me. Okay, now focus here. This is me. Okay, and I have a cousin. This is me, and I have also cousin. Okay, my cousin is living in forest. Okay, I am living in the urban area, something like city. Okay, so let us say that we were living in the 18th century, in 1800 AD. Okay, so I am living in a city, and distance between me and my cousin is about something like about 10 kilometers. 10 kilometers. Okay, my job is to ensure that since my cousin is living in a forest, okay, my cousin needs to alert me if there are any poachers. Or if there is any kind of what we call it as poaching is happening in the forest, or if there is any forest fire, right, or if there is any kind of malpractices that is happening in the forest. Okay, if my cousin is facing any threat, he needs to transfer that message to me. He needs to communicate it to me. In those days, we do not have any kind of television. We do not have any kind of mobile phones. We don't have any kind of letter. You cannot post a letter because the communication needs to be very instant. It needs to be very immediate. Okay, what is the best communication in those days is, okay, you need to have a switch. Let us say that this is a switch, okay, and a small bulb. Let's say that this is a bulb, a switch and a small bulb, right, and a wire. Okay, so let us say that either way. Let us say that I am I need to inform a cousin if I am facing any threat. I need to inform a cousin, or if my cousin is facing any threat, he needs to inform me because we are just 10 kilometers apart. Okay, let us say that I am facing a threat. Let us say this is me. Okay, I am facing an emergency. I'm facing an emergency. How I can communicate? According to us, if I turn on this switch, the switch is going to remain off for a long time. The moment I turn it on, okay, the bulb starts glowing. Then my cousin will understand. Okay, my brother is under threat. My brother is in on emergency. So how this information has been transferred? I just turned on the switch. Okay, if I turn it off, if I just turn it off the other way, if I turn it off, it means okay, I'm not under any emergency because it is always going to be off. When it is found to be off, I'm not under any emergency. So I can pass two messages by using one switch. Yes or no? I can pass two messages. What is the one message? One is what? One is off message. Second one is on message. Right? If you have any switch that you can pass two messages, either you can keep it off forever if you do not find if you're not facing any kind of emergency, or what else you can do? You can turn it on. The moment you turn it on, what happens? Okay, our cousin is going to understand that you are under emergency, right? So this one switch. So when you have one switch, okay, this is called as what in electrical or in electronics. This function is called as what? A transistor. Okay? One bit of memory. When you say one bit of memory, with one bit of memory, you can pass what? You can pass two set of information. Are able to follow? When I say one bit of memory, you can pass two set of information. What are they? You can use either 0 or 1, or you can turn it on or you can turn it off. Is there any possibilities apart from these two messages? One switch can convey two messages, one at a time, turning it on, turning it off. So this is what the one bit representation in any programming language. When you say you have the memory of one bit, with that one bit, what are the possible information that you can store? You can either store true or you can either store false. Okay, so let me understand this. Let me expand this analogy a little bit further. Okay, let us say that. Okay, now focus here. Okay, one bit, 1 or 0. You can pass either, you can store either 1 or 0, or you can store either true or false, whatever it is. You can either represent like on or off. Okay, or you can say yes or no. Yes, no. Okay, any two pieces of information. You can store one information but two possible combinations, on or off. If you use 2 bit, we have 2 bits. Okay, 2 bits are like two electrical switches. Imagine like this. 2 bits are like two electrical switches. You can keep two switches. What are the possible combinations? You can keep two switches off. Okay, this is one of the signal, right? One of the possible signal. Okay, and you can also you can keep either one on and either another one off. Another other possible signal off and on. Okay, off 1 minute, my paintbrush is not working. Okay. Off and on. What are they? Off, on. On. And what are the other two possible combinations? Off, off. I mean on, off. Okay, so with the 2 bit you can say that you can end up in how many possible combinations? 1, 2, 3, 4 possible combination. Okay, when I say 3 bit, 8 possible combination. When I say 4 bits, 16 possible combination. To understand this pattern, 1 bit is representing what? 2 to the power of 0, right? 2 bit is representing, sorry, 1 bit is representing 2 to the power of 1, not 0, 2 to the power of 1. Okay, 2 possible combinations, 2 to the power of 1. 2 bit is representing 2 to the power of 2. A 3 bit is representing 2 to the power of 3. 4 bit is representing 2 to the power of 4. Likewise, if you say 8 bits, okay, if you say 8 bit is going to represent how many possible combinations, how many possible messages that you can deliver? 2 to the power of 8. Right? What I'm trying to say is we are going to understand the primitive data types in detail. So we have something like byte data type, we have something like short data type, we have something like long data type. So each and every data type is going to represent some bytes. If you understand this, that understanding is going to be like a cakewalk. Right? In the olden days, they want to deliver any message. For example, if you are a sailor, okay, if the sailor is on emergency, okay, what he will do, he will transmit the data. He will transmit the data in the form of radio signals to the nearest shore location. He will transmit the information in the form of radio signals. For example, let us say that you want to this sailor is an emergency. Okay, you want to say help. It cannot be transmitted without radio signal. So what they do is, for H they assign a word something. Let us say that they will assign word something like 5. For E they assign the word something like they assign a number something like 9. For L they have a number something like 4. Even for P they have a number something like 6. Okay, this 5, 9, 4, 6 will get converted to a binary number. Okay, let us say that for the 5 is representing what? 101, right? 9 is representing something, any binary number, they will convert this number to a binary form, machine understandable form. It's some random numbers. After this conversion, okay, so this will be transmitted in the form of radio frequency. So the receivers, from the receiver side, they have a lot of red bulbs, something like this. Okay, something like this. They are going to have that from the receiving side. They have a lot of red bulbs. Okay, now if you by the code that you're passing, when the frequency is 101, okay, and this will be turned on. Okay, when the frequency is 1010, okay, these two will be turned on. When the frequency is 10101, right, and these 3 things will be turned on. When the frequency something like when it is 1, it will be turned on. When it is 0, it will be turned off. Okay, by these signals, they can decipher these signals, because this is representing a binary number. Okay, they find, okay, this is representing S. Okay, these signals are representing E. Okay, these signals are representing L, and these signals are representing L. They communicate in the form of Morse code, dots and dashes. Okay, so they transfer the number. Okay, they just play with the frequencies. The frequency is high, they take it as on. If the frequency is low, they take it as off. The combination of on and off is going to give a number. They understand because they have already mapped the numbers to a certain letters. So they will decipher this. So this is how they communicate. So what I'm trying to say is, whatever the things that you want to communicate to a machine, that communication needs to get happened with the binary numbers, zeros and ones. Even if it is a simple data or even it is a complicated data, without zeros and ones you cannot communicate. Okay, let us jump into actual picture now. Binary number system. Now focus here. Binary number system. Okay. For example, you want to do what? You want to store 45. Let me take a value 45. Okay, 45. Okay, 45 is a decimal number. You want to store this decimal number to your machine. Let us say that this is the RAM, electronic machine. Okay. Before storing this to the RAM or before storing it to the machine, okay, there will be a converter. Okay. This 45 needs to get converted to a binary number. How the conversion can happen possibly? You keep dividing this number by 2. Binary means by. By means 2. Divide it by 2 until you find the last remainder. Okay, let's keep dividing. 2 twos. I mean, you get 44 and the remainder is 1. You will place the remainder right here. Okay, and again divide it, keep dividing it by 2. 2 11s, 22. Okay, the remainder is what? 0. And again 2. 2 5s, 10. The remainder is what? 1. Again 2. 2 2s, 4. The remainder is what? 1. Again 2. 2 1s, 2. The remainder is what? 0. Until you find the last remainder 1. Right? You keep dividing it. So now you will rewrite it like from bottom to top. You will rewrite. Okay, what is the number? 1 0 1 1 0 1. Right? So this conversion will convert the decimal number, okay, to the equivalent binary number. Okay, and this is of base 2, because binary number is representing with will get represented with 2 base. This will be stored inside the RAM. Right? Likewise, for example, if you are giving any mathematical operation, let me remove this. Okay, one more example I will give. If you want to perform any mathematical operation, like you want to do the summation of 10 plus 20. So we humans, we can understand the 10 plus 20 is 30. Okay, and you want to do this by using your electronic machine or RAM. Okay, all the arithmetic operation will be calculated on top of RAM. So that's why I'm taking RAM. Okay, there will be a converter. Okay, what this converter will do? First, this converter will try to convert this 10 to the binary number. This is decimal. Okay, keep dividing it by 2. 2 5s, 10, and this is going to be what? 0. 2 2s, 4. The remainder is what? 1. 2 1s, 2. The remainder is what? 0. Okay, 10 has got successfully converted to binary number by the converter. 1 0 1 0. Okay, one more number is the 20. Right, and this 20 needs to get converted to the binary number. Hence, okay, 0. 2 5s, again 0. 2 2s, again 1. Right, the remainder is 1. 2 1s, the remainder is 0. Right, so this is what from bottom to top you will write. Right, so 1 0 1 0 0. Okay, this is representing 10. This is representing 20. Right, then it will be these binary numbers will get actual arithmetic operation. So 0 plus 0 in the binary is 0. 0 plus 1 in the binary is 1. 1 plus 0 in the binary is 1. 0 plus 1 in the binary is 1. And 1. This is the output. Okay, calculation will be happening by converting the decimal to binary first. Right? And it performs arithmetic operation on top of the binary numbers. Right, and again to display this to the end user, again there will be a converter which converts this binary number to the decimal number. Okay, how that conversion is happening. So let's just take this as a take this. Okay, 1 1 1 1 0 you have, right? So let me give you let me also give this. So you are performing 0 plus 1 by using binary, it is 1. 1 plus 0 is also 1. 1 plus 1 is going to be 10. 0 plus 0 is going to be 0. Okay. Binary number calculation, right? So we have the answer. Okay, this is the equivalent binary number for the 20. This is the equivalent binary number for the 10, right? And you got this after performing the arithmetic operation. Okay, now again this needs to get converted to what? This needs to get converted to the decimal number. So what you do, just use 2 and place powers. Increase the significance of the power. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. After this, what you have to do is just ignore the zeroth position. When you find 0, just cross it. You calculate the remaining things. Okay, 2 to the power of 4 is what? 16, right? 2 to the power of 3 is what? 8, right? 2 to the power of 2 is what? 4, right? 2 to the power of 1 is what? 2, right? So 16 plus 26, 27, 20, 30. That is the output. So it will convert the resultant binary to decimal, and it will give the 30 as an output. Okay, 10 plus 20 is 30. We know that 10 plus 20 is 30. How the machine will understand 10 plus 20 is 30? Okay, let me take another example. If you want to perform something like 8 plus 4, a simple arithmetic operation, right? So we know 8 plus 4 is 12. Okay, but if you want to use your machine, to perform this calculation, okay, before even taking it, there will be a converter. This converter first will convert the decimal number to binary, right? You have to convert the decimal to binary, you need to keep dividing it by 2. Okay, 2 4s are 8, 0, 2 2s 4, 0, 2 1s 2, 0. Okay, you got from bottom to top, you have to write. Okay, what is the value? 1 0 0 0 base 2. Okay, after this you have one more number called 4. Okay, this is the decimal number, you need to keep dividing it by 2. 2 2s 4, balance is 0, remainder is 0, 2 1s 2, and remainder is 0. Okay, and if you take it from bottom to top, it is 1 0 0 base 2, right? And there is an addition operator plus. Okay, and you do addition. Okay, 0 0 for binary, 0 0 0 plus 0 is 0, 0 plus is 0, 0 plus 1 is 1, and 1 nothing is also 1. You got this as an output in the form of binary. Okay, so the machine will have this number 1 1 0 0. If this machine wants to give this number to you in the console, there should be another converter which is going to take care of the binary to decimal conversion. So here decimal to binary, D to B. While taking it as an output, it is going to be what? B to C, binary B to D, binary to decimal, right? If you have a value like 1 1 0 0, if you want to convert it to decimal, this is binary, right? If you want to convert it to decimal, just keep using 2's. Start from 2, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. You should increase the significance of the power from 0 1 2 3, like that. It has to keep going. After doing this, what you will do, just ignore the 0th places, ignore this, okay, and also ignore this. Don't ignore ones. Now we calculate ones position. You have two numbers, 2 to the power of 3, 2 to the power of, just add this 2. 2 to the power of 3 is going to give what? 8. 2 to the power of 2 is going to give what? 4. 8 plus 4 is what? 12. Okay, and 12 will be given as an output in the console. These many things are happening internally. Able to follow everyone? Why the binary system is very important? Because these things are very important to understand the primitive data types. Are you able to follow? Or you want me to present it in a different way? Yes or no? Someone has escaped. Huh? Dinesh is not here. Right? So likewise, you should understand how this conversion is happening and why we need to convert, why the system is using zeros and ones, why machine understands only zeros and ones. For that I have given example. These are the examples that I have given, right? So if you, this is the best example to communicate, to perform any communication, okay, with respect to machine, and again machine also follows this concept, this bit concept. If you have one bit, you can store two possible values. If you have 2 bits, 4 possible values, 3 bit, 8 possible values, 4 bit, 16 possible values, likewise 8 bit, 64 possible values, right? So this is the idea for the introduction of what? Introduction of primitive data types. This is the idea behind the scenes to introduce what? Primitive data types. This is just an idea. Based upon this idea, they have introduced what? Primitive data types. Okay, there are 8 primitive data types in Java. First one is you have something like byte, second one is short, third one is integer, fourth one is long. Each and every primitive data type is going to use some bits and bytes. Long, fifth one is float, sixth one is double, okay, and you have what? You have char, and last one you have what? Boolean. To represent any data, it can be a numerical data or non-numerical data. We are supposed to use what? We are supposed to use one among these primitive data types, right? And again, if you talk about size, okay, so byte, the byte data types, the size of the byte data type is 1 byte itself. Okay, the size of the short data type is 2 bytes. Okay, the size of the integer data type is 4 bytes. Size of the long data type is 8 bytes. And the size of the float data type is again 4 bytes. Okay, the size of double data type is 8 bytes. Okay, the size of char data type is 2 bytes. The size of Boolean data type is only 1 bit. Why 1 bit? We have just understood Boolean data type. 1 bit means it can either store true or false. That's why the Boolean data type can possibly store two values, which are what? Either one you can store true or you can store false. Okay? But again, this true and false will get represented internally in the form of ones and zeros. Ones and zero. So when you have a memory size something like 1 bit, let us say that this is 1 bit. Okay? At any point of time, you can either store 1 or you can either store 0. 1 bit. 1 bit means 2 to the power of 1. 1 bit means 2 to the power of. Okay. So these are the sizes. These are the sizes of primitive data types. Okay. And after this, so you can do further calculations. Okay. 1 bit is also called as, you can, if you want to find number of bytes, you want to find number of bits on each and every byte, you can do 1 into 8 into 8. It is possibly what? 8 bits. Okay. So 2 bytes. 2 byte means how many bits? 2 into 8, 16 bits. Okay. 4 bytes. 4 bytes means how many bits? 4 into 8, 32 bits. Okay. 8 bytes is what? 64 bits. Right? And again 4 bytes, what? 32 bits. 8 bytes is what? 64 bit. 64 bits. Okay. And the 2 bytes can be converted to what? 16 bits. 16 bits. And for Boolean, there is only 1 bit. Smallest data type is Boolean data type. Okay. So if in interview, if they are asking you size, what is the size of int? You should say 4 bytes. What is the size of double? You should say 8 bytes. What is the size of short? You should say 2 bytes. And also there is a range. There is a range. So they are coming to a conclusion. So they are saying the first 4 primitive data types, you can store any numerical values. It can be a negative number or a positive number. Any numerical values you can store from any bigger negative number, any number you can store, but it can be negative to positive. Okay, and these two, float and double, you can store the number with the fractional part. The fractional part, when I say with the I precision, like petroleum price 0.767, like account balance 10,000 point something like this, 77 something like this. So, and when you take Java character data type, you can store things like, you can store, see, the character data type is supporting things like, you can store alphabets A, B, C. Also, you can store the Telugu letters A or A. All the Telugu letters. Also, you can store all the Tamil letters A. Also, you can store all the Hindi letters. Right? So, it is going to support majorly all the international languages. Almost all the major international languages. Java cat data type, it is going to support all the major international languages. I will also help you to write the letters in Telugu, in Tamil, in Hindi by using the cat data type. We are going to discuss each and everything in detail in the future. So this is just an introduction about bits and bytes. Apart from that, nothing. We haven't seen anything today. We just discussed about the evolution of bits and bytes, evolution of memory, evolution of computer storage, evolution of computer storage. Okay, why we are storing data is in zeros and ones. That understanding I have just given you, that understanding. Even if you don't remember all this also, no issues. Okay, from tomorrow, don't miss any classes from tomorrow, because this byte is going to take at least 2 classes. Each and everything is going to take 2 classes. So by this, if you understand all these things, you will not make even a small mistake while writing a Java program. Making sense, everyone? And also trust me, you will not get the complete deep diving concepts anywhere. You cannot find these things anywhere in the YouTube channel.